Alrighty. We are now in chapter 18, and chapter 18 is on the cardiovascular system. So we're going to start off with heart anatomy. And I went ahead and put this picture up here because I wanted you guys to kind of look at the heart and just kind of get a general kind of, layout of the heart. So, and we're going to go over all this again in more detail later, but we have, the heart is basically two pumps, right? It's got a left side, which is a pump. It's got a right side, which is a pump. And on the right side, we have the right atrium, and we also have the right ventricle. And this is going to be pumping blood to the lungs. On the left side, we have the left atrium and the left ventricle, and this side's going to be pumping blood to the rest of the body. There are some differences we can see. So, like, for example, the left side, the actual ventricle is thicker. And this is because the left side has to pump to the whole rest of the body, whereas the right side is just pumping throughout pulmonary circulation. There are a number of great vessels. So we have the superior vena cava, inferior vena cava, pulmonary trunk, aorta. We'll go ahead and we'll get into all this. So the heart is a transport system. It's a pump, basically. It's two pumps, like I just said. The right side is going to receive oxygen-poor blood from the tissues. It's going to come in through the inferior and superior vena cava, and then it's going to pump blood to the lungs. And in the lungs, CO2 is going to be dropped off and O2 is going to be picked up. And this is going to be called the pulmonary circuit. The left side, again, which is a kind of a different pump, is going to receive oxygenated blood from the lungs, and it's going to pump blood to the body tissues via the systemic circuit. So what we need to remember here is that the right side is going to pump via the pulmonary circuit, the left side, the systemic circuit. The receiving chambers of the heart are the right and left atria. The right atrium receives blood returning from the systemic circuit, again via the superior vena cava or inferior vena cava. And the left atrium is going to receive blood returning from the pulmonary circuit. So if we, again, remember what we just learned already, is that the right atrium is going to be receiving oxygen-poor blood, and the left side, the left atrium, is going to be receiving oxygen-rich blood. And then we have the pumping chambers of the heart, which are the ventricles, the right and left ventricle. The right ventricle is going to be pumping blood through the pulmonary circuit. The left ventricle is going to be pumping through the systemic circuit. And this is kind of what we would see. So if we have the right side, we'll just start here at the right atrium. We have right atrium go to right ventricle up to pulmonary circuit. It's going to, blue typically denotes deoxygenated blood, and red typically denotes oxygenated blood. And then if it's this purpley color, I'm trying to get my cursor back. I've lost my cursor. There it is. If it's this purpley color, that means that the oxygen is being, in this particular case, this means that the blood is becoming oxygenated. When it's down here, this means that the oxygen is actually being dropped off to the tissues. But anyway, back up to the lungs. So we have the pulmonary arteries bring the blood to the lungs. It's going to drop off the CO2, pick up the O2, bring back this oxygen-rich blood via the pulmonary veins. Going to come into the left atrium, get pumped into the left ventricle, and then from the left ventricle out the aorta, and then to the rest of the body. And then back up and back into the right atrium. The heart itself, which we've already seen a picture of, is about the size of a fist and weighs less than 1 pound, which is actually pretty impressive if you think about it. It's a little 1 pound muscle or less than 1 pound muscle that pumps all the blood throughout the body. It's located in the mediastinum between the second rib and fifth intercostal space, on the superior surface of the diaphragm, and then 2/3 of the heart to the left of the mid-sternal line, and then anterior to vertebral column, posterior to sternum. So what does all this mean? It means, here, let's just look at a picture. So the mid-sternal line is here. It's going to be kind of oriented to where it's shifted a little bit to this side, which would be to the left side. You can see the way that the heart is actually oriented in the chest, and it sits on the superior surface of the diaphragm. It's going to sit behind the sternum and in front of the vertebra. This is just again showing, be careful with this diagram. This diagram is a little tricky. And the reason it's a little tricky is because you may be tempted to look at it in a kind of a different way than I think they intended for you to look at it. I lost my cursor again. Okay, here it is. Let's see. This right here is supposed to be the left lung, right? And this is the vertebra, which means that you're looking at this from like underneath it. So you have to just be really careful about how you're looking at this, because again, the heart's kind of shifted to the left side a little bit, but it does sit behind the sternum and in front of the vertebral column. The base leans towards the right shoulder, and the apex toward the left is pointing towards the left hip. And then we have the pericardium. And the pericardium is a double-walled sac. It surrounds the heart, and it's made up of 2 layers. So the outer layer, or the superficial fibrous pericardium, has functions to do a number of things, including protect, and then anchor the heart to surrounding structures, and to prevent overfilling. And then there's a deep 2-layer serous pericardium, and this is going to be composed of, like I just said, 2 layers. And there's a parietal layer and a visceral layer. And the parietal layer is going to line the internal surface of the fibrous pericardium. Excuse me. And the visceral layer, or the epicardium, is going to be on the external surface of the heart. I'm going to show you a picture of this so you can kind of see where everything is located. Between the parietal and the visceral layers, you're going to find a fluid-filled cavity called the pericardial cavity. And the purpose of the pericardial cavity is to decrease friction. So out here, we have the fibrous pericardium, and then we have the parietal layer of pericardium sitting right below that fibrous pericardium. And then the epicardium, or visceral layer of the serous pericardium. And then between, you're going to have that pericardial cavity, where this is going to be filled with fluid, which will help to decrease friction. There are 3 layers of the heart wall. There's an epicardium, a myocardium, and an endocardium. And endocardium is on the other page. So epicardium is the visceral layer of the serous pericardium. The myocardium, this is circular or spiral bundles of contractile cardiac muscle cells. And then we have something called the cardiac skeleton, which is crisscrossing, interlacing layer of connective tissue. This is going to anchor cardiac muscle fibers, support great vessels and valves, and limit the spread of action potentials to specific paths. So this right here would be the myocardium. You can see how it's the bundles that it's talking about. And then we have the endocardium. This is the innermost layer. This is actually continuous with the endothelial lining of blood vessels. And it's going to line the heart chambers and cover cardiac skeleton of valves. And this is just showing the different layers again. So we have the epicardium on the outside. Remember, epi means above. Then the myocardium, the middle, the actual kind of the muscle. And then the endocardium, which is going to line the inside of the heart. Internal features. So the heart consists of 4 chambers, which we've talked about. There are 2 superior atria and 2 inferior ventricles. And then there's an interatrial septum, which separates the atria. And there's a fossa ovalis, which is the remnant of the foramen ovale of the fetal heart. And the foramen ovale is actually a shunt that's found in the fetal heart, which allows blood to go directly from the right atria to the left atrium, the right atrium to the left atrium. And it does close after we're born. And then there's the interventricular septum, which separates the ventricles. And so this, again, is a picture of the heart. And as a reminder, we have right atrium, right ventricle, left atrium, left ventricle. The atria, again, are the receiving chambers, which means that the blood is going to enter the heart through the atria. They're small, they're thin-walled, and they contribute very little to the propulsion of blood. Then we have these appendages that help to increase atrial volume called auricles. And the right atrium is going to receive deoxygenated blood from the body. 3 different veins empty into the right atrium: the superior vena cava, the inferior vena cava, and the coronary sinus. So the superior vena cava is going to return blood from body regions above the diaphragm, the inferior vena cava from below the diaphragm, and the coronary sinus is going to return blood from the coronary veins. Then we have the left atrium, which is going to receive oxygenated blood from the lungs, and 4 pulmonary veins will return blood from the lungs. So, I keep losing my cursor. Inferior vena cava is going to send blood in, superior vena cava, and then also the coronary sinus would come in. And then as far as for the left atrium, we have 4 pulmonary veins, 1, 2, 3, 4, that are all going to empty into the left atrium. The ventricles are the discharging chambers. They're going to make up most of the volume of the heart. The right ventricle is most of the anterior surface. The left ventricle is the posterior inferior surface. And then we have these things called papillary muscles, which project into the ventricular cavity. And we have these things called chordae tendineae. And I'm about to show you what these do. Oh, no. Here we go. So we have the papillary muscle down here. That's what this is. Papillary muscle, papillary muscle, papillary muscle, papillary muscle. And then attached to the papillary muscle, so between the papillary muscle and the valve, and we're going to talk about the valves a little bit more, but we have these chordae tendineae, and they're attached. Ventricles, discharging chambers continued, so the walls are going to be thicker than the atria. They are the actual pumps of the heart. The right ventricle is going to pump blood into the pulmonary trunk. The left ventricle is going to pump blood into the aorta, and the aorta is the largest artery in the body. So, right ventricle goes into the pulmonary trunk. Left ventricle, kind of hard to see, but it actually would go underneath this and up into the aorta. Heart valves. So we have valves in our heart, and what it's going to do is it's going to help to ensure that blood flows in one direction. They open and close in response to pressure changes, and we have two major types of valves. The atrioventricular valves are going to be between the atria and the ventricles, and the semilunar valves are going to be located between the ventricles and the major arteries. There are no valves found between major veins and atria. So where the superior vena cava comes in, there's not a valve between the superior vena cava and the right atria. And this is not problematic. And the reason it's not problematic is because, one, the blood that's coming in, the incoming blood, actually has inertia, and that's going to prevent backflow. And inertia is just the whole concept that once something is in motion, it wants to stay in motion, and when something's at rest, it wants to stay at rest. So when the blood is like being pumped back to the heart or flowing back to the heart, it has enough movement coming in that it's going to prevent the backflow. And then heart contractions actually compress venous openings. So as the heart contracts, it'll actually clamp down on the superior and inferior vena cava and the other vessels as well. This is just showing heart valves. And we'll talk about, I think this image will show back up again, but I'll just show you the valves real fast. So this is the left atrioventricular valve here, which is also known as a mitral valve. And this one right here would be the right atrioventricular valve, also known as a tricuspid valve. This would be the aortic valve, and this would be the pulmonary valve. And they're going to be called the aortic semilunar valve and the pulmonary semilunar valve. All right. We have two atrioventricular valves. Again, they're both going to prevent backflow into the atria when the ventricles contract. And like I just said, the right AV valve is called the tricuspid valve. It's made up of three cusps, and it's between the right atrium and ventricle. And then we have the mitral valve, and the mitral valve is the left AV valve, also known as the bicuspid valve. So either way, I probably will call it the mitral valve, but it doesn't hurt to know it as the bicuspid valve as well. It's made up of two cusps. That's where the bi comes from. Bi means two. So two cusps, and it's going to lie between the left atrium and ventricle. And then the chordae tendineae is going to anchor the cusp of the AV valves to the papillary muscles, and that's going to function to do two things, or two really important things. Hold the flaps in the closed position and prevent flaps from everting back into the atria. So this is showing you the papillary muscle and the chordae tendineae, and then it would be attached to the tricuspid valve up there. And this is showing the same thing. This is your tricuspid valve, and then the little strings are the chordae tendineae, and then down here you would have your papillary muscle, papillary muscle, papillary muscle. All right, so how does this work? Blood is going to return to the heart, and it's going to fill the atria. As the pressure in the atria rises, it's going to force this valve open, okay? And this is going to cause blood to kind of passively flow into the ventricle, okay? So then the atria is going to contract, which is going to force additional blood into the ventricle. Then the ventricle will contract. I'm trying to get my cursor back. The ventricle will contract, and when the ventricle contracts, the AV valves will close. So you can see this is closed, and this is going to prevent blood from flowing back into the atria here, atria here. And this is what you would see, something like this. It's going to be closed. Papillary muscles contract and chordae tendineae tighten, which are going to prevent flaps from everting into the atria, which is something you would not want. You would not want these flaps to evert back into the atria, because then the blood would flow back into the atria. Then we also have two semilunar valves, and they're going to prevent backflow from major arteries into ventricles. They're going to open and close in response to pressure changes, just like the AV valves. And each valve is going to consist of three cusps that resemble roughly a half moon. There's the pulmonary semilunar valve, which is located between the right ventricle and pulmonary trunk. An aortic semilunar valve, which is going to be between the left ventricle and the aorta. And all this is saying here is we have ventricles contract. So remember, when the ventricles contract, this one's going to close. This AV valve is going to close. But then the semilunar valve is going to open and blood is going to flow through here. And then also this other semilunar valve, which we can't see, is going to open and blood is going to flow out there. As the ventricles relax, the intraventricular pressure falls. And when that happens, the blood will actually flow back, and it's going to cause the cusp to close, or the cusp of the semilunar valves to close. And then here are your questions. All right, that's all I have for the first talk.